back and kind of review. So what we're talking about right now in this chapter is right triangles. Okay, so every right triangle is similar if they have one angle the same, because that means the other angles are the same. Okay, so in it we label it like this. We label the right angle as C. So this side is C. It doesn't matter which one you call A and B, but across from A is little a and across from B is little b. Okay, so that's how we do it. We do that.
Is that a flying squirrel? That used to be.
What?
Right here.
Oh, it looks like a flying squirrel, yes. It's probably talking about something about its flight pattern. So, in there. So, we know this is true, that a squared plus b squared is equal to c squared. So, in all right triangles, that is true. Okay, that's called the Pythagorean theorem. That is the most common thing about right triangles that you will ever use. Okay, Pythagorean theorem is just what you use about right triangles. The next things that we talk about are these ratios. So because right triangles with similar angles are all similar, thank you, then we know that there's constant ratios and they're given specific names. Okay. Yesterday we talked about the tangent. Okay, it's actually spelled this way, but it's the tangent of an angle in a right triangle. And because it's a specific ratio of sides, it's a ratio that's always the same. So when I take the tangent of an angle, I'm actually getting a ratio of the sides, and specifically the sides of the opposite leg over the adjacent leg. So if I put into my calculator tangent of 30 degrees, it's going to give me the ratio in decimal form of the opposite leg over the adjacent leg in that right triangle. Okay, so that's what it's really giving me. So the tangent of the angle is a ratio of the sides, specifically the opposite leg from the angle and the adjacent leg of the angle, I should say of angle. Okay, and that's what you get when you put in the tangent. Okay, so you're getting that ratio if you plug that into your calculator. So if I say tangent of 42 degrees, and it gives me a number in my calculator, so if I hit tangent 42, I'm going to get 0.9. So what this is telling me is if I were to look at my opposite leg over my adjacent leg in my triangle, it's going to have a ratio of 0.9. Okay, so this is the ratio. So this is the ratio in decimal form. Now, I'll give you a hint. Most tangents are not going to be exact numbers. You're going to have lots of them out. Round to the nearest thousandth. That's about the best. That's 3 places, 3 decimal places. So round to about the nearest thousandth. This one was 0.900. So I'm just going to leave it as 0.9 because it's 0.9004. 4 doesn't make it round up at all, so I would leave it there. Okay. So that's what we looked at yesterday. You can then go backwards from this. If you know the opposite side, let's say it's 7 over the adjacent side, which is 15, then we have the ratio. So this is the ratio of the adjacent or the opposite over the adjacent. So if we find that by looking at it, we can actually find from this, we can find the angle measurement by using the tangent -1 of 715. And that will actually give us the angle measurement. So if I did that in here, and on these, it's just the second command with the tangent, 7 divided by 15, and I get that it's 25 degrees. So this is going to give me the measure 25 degrees. So I know that that angle in that triangle is 25 degrees if it has this ratio of sides. So this, when you put the input in, it's the angle measure. The output is the ratio. If you put the ratio in, you're finding you use the inverse, the -1 button, and it gives you out the angle measure. Okay, so that's what that's doing in that case. Okay, so just clarifying all those things. So that's one of the most important, one of the ones. There are 3 different ratios that we use in right triangles. Okay, this is one of them, the tangent. I'm gonna make sure everybody's got that down. Get down what you need on that.
Get up there. Speed notes. Converting to
I'll take that.
good. Nice.
Okay. Jake, did you bring your tab?
Join the guards.
Okay.
I also brought.
Good.
I just noticed it.
Yeah.
Give me the test right now, and then the homework will get together and gather that up.
Let's see here.
Anybody else have a test they need to get?
I did the test at like 10 o'clock.
Oh my gosh. Okay.
I
He
didn't
was running
finish
on
till
steam.
12:30.
How are you doing on getting this down? I know some of you.
And then you did the test. At 3 a.m. No, it's actually crazy when you get tired and you're like thinking about math or something. Like your brain actually stops.
You almost
mathing,
done
like
on
you
that?
start, actually you start like not being
I
able
almost
to
did it. I sat
comprehend
there and
it.
stared at it for like 20
Oh
minutes in
shit.
anger. It was like, why are you? I couldn't remember how to do it. And I just like perfectly searched through my notes until
Yes, it is.
I found the correct notes and I stared at them and tried to comprehend.
I did that problem study yesterday. Correct. I didn't read it.
Yeah, I was thinking about trying to connect.
Okay, so we're gonna do some other
Getting all mine.
ratios now, the new ratios. And then I'm gonna teach you something that you can remember, how to remember these different ones, a little saying. Okay, it's really silly, but you know, that's how it
This
goes.
is still 11:5.
This is still 11.5. Actually, that was 11.4 I just went through, okay? I was just reviewing what we did on 11.4, okay? So 11.5, we are gonna talk about the sine. It's actually spelled like this. The sine of an angle in a right triangle is the ratio of the opposite leg of the angle divided by the hypotenuse. So really, if you have a sine, which we abbreviate just sin, so a lot of people will say sin when they see that. It's really the sine, okay? The sine of an angle like 30 degrees is really going to be its opposite, the ratio of the opposite leg of the angle and the hypotenuse. Okay, so if I wrote 30 degrees in there, and again on your calculator, you will see a sin button or a sine button, S-I-N. Okay, so when you put it in, you would put in sine and 30 as long as you're in degrees, and it tells me if my angle is 30 degrees, then the opposite leg compared to the hypotenuse, the opposite leg is half of the hypotenuse, okay, because it's a 0.5 ratio, okay? So this is of this angle, this is the ratio of the opposite over the hypotenuse. And I abbreviate O over H because that's easier than writing all that out. Very similarly, it has an inverse one. So if you have the ratio O over H, okay, opposite leg of an angle, over the hypotenuse, then you can find the angle measure by using SIN -1 of the ratio. So let's say I put 17 over 19. On these, the hypotenuse is always going to be the longer one. Just realize that when you're doing hypotenuse, it's always the longer side here. So in this case, if I do inverse sine of 17 divided by 19, I come out with an angle of 63.5 degrees. So this is my angle. This was my ratio. Okay, so again, it relates. You can go back and forth. If you have the angle, you can use it to find one of the legs. If you have the legs and the hypotenuse, the measurements, you can find the angle from it. So that's something that you can do in, it's called trig. That's one of the basic functions in trig. It's a trig ratio. Okay, so there's the tangent ratio. There's the sine ratio.
Is there a cosine?
Yes, there is. Okay, I want to make sure everybody has this before we
I
get
saw
it.
COS.
Yeah, COS is cos, which is really cosine. Okay, so when you look at those, that's the cosine. Sin is really the abbreviation for sine. We don't call it sin of an angle. An angle does not sin. Okay, that's what we do. I'm making sure everybody gets this down before I go on. Give you some chance.
What? Trying to make this mechanical pencil into a pen, it wasn't working. Well.
Yeah, that wouldn't work.
That's kind of crazy. That's trying to like figure out how to.
Over hypotenuse, that's correct. Then sine of 30 degrees
Yeah.
is equal to 0.5.
That's a ratio. I love over engineering things.
What is the number under 0.5? What is that?
That just says
what is-
ratio of
What is that
opposite over
behind
H.
ratio though?
It's saying that the
No,
sine,
below the 0.5.
Looks like a
right
carpenter hammer.
Look, yeah.
oh, that's
that.
an arrow.
Oh,
That's
okay.
not a number.
I was like,
You know what I'm saying? The hammer.
That's the ratio.
Nothing else.
Just
Pure carpenter.
You mean the hammer?
Yeah, carpenter hammer specifically. There's a lot of different types of them. Titanium hammer.
That's how I grew up. I never had Smith.
Okay,
Mostly.
Wait,
hold on.
hey,
Over there.
I kinda like that, I think you converted me. Good.
Yeah.
yes,
Are we gonna see examples of this?
I've kind of given you one. I did sine of 30 degrees.
No, I mean like in a triangle.
Yeah, I'll
Okay.
do that once I get done. I'm gonna do a triangle afterwards, and we're gonna look at the cosine, sine, tangent of all of
I
them.
need to see
Okay,
how it works.
what you looking
Yeah, that's
for?
true. Or else
I
we're
don't
gonna
understand
forget.
it. Yeah. No, good.
Whenever she assigns something.
I'm start bringing my felt Sharpie pens.
You do.
Dude, this goose down jacket.
Okay, Jake, you okay?
It's so small.
Yeah.
No.
Okay. Our next one, as Paxton
Shove it in your
said,
backpack.
because he looked on the calculator, it's called the cosine. Okay, and it's kind of interesting. We'll see why it's called the cosine. It goes along with sine. Okay, so it's the cosine like this of an angle. Oops, I can't spell. Of an angle in a right triangle is the ratio of the adjacent leg of the angle over the hypotenuse. Okay. So it's that angle that is part of the side that's part of the angle over the hypotenuse. Okay. It's related to sine, so if you think about it, sine is the opposite leg over the hypotenuse, and cosine is the adjacent leg of the hypotenuse. So one is sine, one's cosine, because they are the two parts that you could have. You can't have any more. Okay. So let's say I have a angle of 63 degrees, and I want to find the ratio of its adjacent side over its hypotenuse. We can just put it into the calculator under COS. And so if you say COS of 63, I get 0.454. 0.454. So that's the ratio of those two of 63. It's the ratio of the adjacent over the hypotenuse. So here's your angle again. And here is your ratio. That's what it gives you. I'm really making sure that you understand when I put the cosine in, it's of the angle and it gives you a ratio. When we do inverse cosine, it's the opposite. You put the ratio in and you get the angle. So if you have the ratio of adjacent leg over hypotenuse, then COS minus 1, you put in the ratio and you will get out the angle. So let's say the ratio is 3 to 22. Okay, I'm making these up so you never know what we get. That's a pretty small ratio, so I'm going to assume it's a pretty small angle. Let me see if that's right. So the cosine, oh no, actually it will be a big angle because this is my adjacent one. Clear, inverse cosine 3 divided by 22, 82 degrees. So if I have this ratio in my triangle, I can find the angle, it will be 82 degrees. Okay. So those are the three that you use. Those are the bases for trigonometry. Basically, you're going through sine, cosine, tangents. You're looking at them. We actually graph these as functions on an XY coordinate plane, and we start doing things with those. And it actually relates to waves. So sine function is a wave function. So is cosine, it's a wave function. So those actually relate to some of radio waves, to light rays. Because those are all waves. And so they actually relate, cosine sine functions eventually relate to those wave functions. And so that's why we study these. Because what happens is we put it into a unit circle, and basically if I get a bigger angle, it just starts repeating itself because another angle is the same, and we won't go into a lot of that right now. That's what trig is all about. Trig is all about talking about these waves functions, because when we put them on an XY graph, the sine function and the cosine function become waves like this. I mean, they're actually a steady wave. So the more you put it together, it's a different wave. The more you spread it apart, it's a different wave. You can relate those and explain sounds with those. You can relate those and explain all the different lights that we have because they're all different wavelengths. We can do those which is related to light waves, which is all the X-ray, gamma rays, all those kind of rays that you talk about. Those are all light waves and how they emit, and they all have a different frequency in there. And so we start looking at that. That's the study of trig. Okay, it's based on right triangles, but it goes into a lot more. Okay, so there are three, and this is a acronym that's been used, especially when we made you memorize these formulas, which if you go on to trig or any other thing, you will have to memorize it, but if you call it SOHCAHTOA. So go SOHCAH, your TOA.
Sounds like a Star Wars character.
Yes. So this is sine, which is opposite over hypotenuse. This is cosine, which is adjacent over hypotenuse. This is tangent, which is opposite over adjacent. SOHCAH, your TOA. SOHCAH. Toa. Or it's an Indian name. I have no idea what it is. It's made up.
I was thinking of Ahsoka.
I just remember, I always remember how I was taught it. You go SOHCAH, your Toa. So, SOHCAH, your Toa. Anyway, that's one way to remember what they are, what the ratios are. So that is a silly way, but when you had to memorize all this, for tests, that was a way to remember it, okay? And if you go into trig, they're going to expect you to know that off the top of your head. So if you have any problems remembering it, go back to SOHCAH and you'll know, okay? That way it helps you. Okay, so let's look now at one. So let's say we have a right triangle that looks like this, okay? This is my C, this is my A, this is my B.
Is this for cosine or sine?
I don't know, we're gonna do both,
Oh, okay.
okay? So I'm gonna give you two measurements. I'm gonna give you this, 7 and 35 degrees. Okay. Based on this, we can find all the other measurements of this triangle. just given this information, we can find all the other measurements, okay? First thing we can do is we can probably figure out the other angle. If I'm given one angle, figure out the other angle. What is the other angle going to be here?
90 degrees.
Well, no, we have that. We have the 90 degrees, we have the 35 degrees. What is the other angle gonna be?
45.
Nope.
55.
55. We have to, because a triangle always adds up to 180 degrees. We know that there's 90 degrees and 35 already, so if I take those two away, I end up with 55 degrees. So this angle is gonna be 55 degrees, okay? So always, if you have two of the angles, find the third angle. That's always a first step, okay? Now, we want to find the opposite side or the adjacent side. Which one do you want to find first? Of which angle? Give me a relationship that would explain the one side compared to the 35-degree angle. Give me something that I could state. Think about cosine, sine.
So
Let's
We
call
could go
these to
sine,
these things. I'm gonna call
opposite.
this X and that Y right now. Okay, that'll help us to give a statement.
So you could go opposite of bx over hypotenuse 7,
Okay, and what would be
Sine.
that?
x over 7.
Well, okay, so X over 7 is a ratio. What ratio is that? Is that the sine, the cosine, or
That's
the
sine.
tangent? That is the sine, okay? The sine of what angle?
Of 35.
Of 35, of B, that's correct, but we want the 35. Because we can put in the calculator, we can calculate the sine of 35 by putting it in our calculator. Okay, so what we now have is X over 7 will equal whatever the ratio our calculator gives us, because we know what the ratio is gonna be. What is that gonna be?
0.574.
574, 0.574?
Yeah.
I have a question. Can a sine ever be greater than 1? I want you to think about that. Can a sine, when I plug in sine, will I ever get a number greater than 1? Okay, let's think about it. What is our bottom number here?
7.
Yeah, but what is it normally? What is that side called?
Hypotenuse.
The hypotenuse. Which is the longest side of anything in a right triangle?
Hypotenuse.
The hypotenuse. So if the hypotenuse is in the bottom, will we ever get a number over 1?
No.
No, we won't. So if you have a number over 1 when you hit sine 35 in your calculator, something has gone wrong, okay?
Can you get
got
it in tangent though? Because
Yes,
it's
tangent
adjacent.
you can, because those are the two legs, and there is not one that's bigger than the other. Yes, tangent you can get it bigger, okay? How do I use this now to find X? Yes,
Then you could do
Multiply 5.574 by 7.
yeah, it's algebra now. We're multiplying to get X, so we just multiply 0.574,
Which equals
what is it?
4.
Okay. So that tells me that this is 4, okay? So this is B. We found one of the other sides. The only thing that's missing is Y. There are a lot of ways to find Y. How would you like to find Y? Somebody speak up and tell me how you'd like to find Y. Yes,
We could do sine again.
we could do sine again. And what would the relationship be?
It would be y over 7,
Okay, Y over 7, and that's the sine of what?
55 degrees.
Sine of 55 degrees, okay? So we can use the same one, because if you look at 55, The sine is the opposite over the hypotenuse, so it would be y over 7. That's one way to do it, okay? Somebody give me another way to do it. So this is one way. Somebody give me another way to do it.
Mhm.
Aaron, what's one other way I could do it? Besides using the sine, what else could I use? Yes.
At this point, because you know two sides,
You
couldn't you use algebra and the Pythagorean theorem?
Yes, you could use the Pythagorean theorem. That is so true. We could use 4 squared plus y squared equals 7 squared. So that's another way.
Could we do cosine adjacent?
Sure,
Right.
cosine, what would it be?
Y over 7.
Equals
Sin or cosine 35.
35. Okay, that's another way you could do it. There is one more way. Actually, a couple more ways, but it's the same idea.
Tangent.
Yes, I could use
Over.
tangent. So what is the tangent? Again, you have to figure out what angle am I looking at.
4 over y.
Okay, so you do 4 over y.
Wouldn't it be y over?
You could do both, thank you. 4 over y equals, and y over 4 equals. This is the tangent of what?
35.
That's the tangent of 35, because it's the opposite over the adjacent, that's 35. Here we have the opposite y over 4, which is the tangent of 55. 5 ways to find that last measure. I don't care how you do it, okay? You can use any of those ways to find it. If you went through and calculated all of them, they should give you something relatively close, okay? So let's do this. Aaron, will you do number 1? Method 1. Harrison, I want you to do method 2. Okay. Jake, do method 3. Okay. Luke, do 4. And do you have a calculator, Linnea?
I don't.
You don't, okay. Paxton, do number 5. So we're gonna see what y comes into in each case.
Actual case is so in Oregon.
Wait, let me see what you-
Made in Oregon, huh?
Yep.
That's
Okay,
cool.
4 over, no, it's
First thing,
how do you?
that's the last thing they ever made.
First, right there.
And the first thing.
4 over y equals.
Sorry about that.
I
Didn't make any.
It's off the gym.
I turn it on and I get an immediate detector.
No, I'm just standing out of the lights way so you
That's
can
not a
see.
good sign.
And then you have a
Whoa, that's not a good sign.
Oh, Linnea, I have stuff for you. Do you have your text?
Okay, wait, I'm doing number 4, right? No.
I just know Harrison.
Wait, Miss
got
Em.
number 2.
Can you finish it up for class?
Just do algebra.
Okay.
Wait, Miss Em.
Yes.
Oh, sorry.
As you go and have somebody properly, then bring it back to me.
Miss Em, I'm doing 4.
Okay, so let's start. Who did I give this one to? I don't remember. Aaron, what'd you get?
5.74.
So you get y equals 5.74. Okay. Harrison, what'd you get? You're still working on it.
I got y equals 33. Which is, I know I did something wrong.
Maybe you did this, need to do the square root of 33.
Maybe, perhaps.
Give me 0.7.
5.7.
I could.
You didn't mess it up that badly.
Okay,
Wasn't done.
so who did the third one?
Jake.
Oh, yeah, I think it was.
Cosine of 35.
Yeah, it's, I got
Okay.
0.7.
You got 0.7. Okay, what did you get for cosine of 35?
Cosine?
Of 35.
Divided by.
It's 0.8
I mean,
about, or 0.82.
Cosine of
There
35.
we go.
Okay, and then you multiply that by 7?
Oh,
573.
0.573.
5.73.
Tangent of 35 is not equal. And y equals 5.7.
Who did the fourth one for me?
Lou.
That's y equals 5.7.
5.7? Okay. And who did the
I
last
did
one for me?
5.7125.
5.7125, okay.
So they're all like almost the same.
Okay. If I were to round to the nearest, if I were round to the nearest tenth, notice that we would get 5.7 on every one of these, okay? Why are they off just slightly?
Because we're rounding.
Because we're making rounding errors.
Yeah.
So when we're doing this, it's going to give us very close, but not exact, because you're making some rounding errors in the process, okay? This 4 here, that threw that one off definitely, because 4 was probably rounded. It probably wasn't exactly 4. It might have been, I don't know, but it might not have been exactly 4. And so rounding errors, but we're getting it to the nearest tenth, okay? Very, very close. It really depends on how far your calculator takes it out, or if you didn't use the whole thing times the 7 and just used a portion of it times the 7, yes,
If I brought calipers, I could get more than a 10.
probably. I bet you could. Hey, it's a tool. I'm not disagreeing to the tool. Okay, the tool works. Okay, I'm just saying that when you're working with other things, so a lot of things that they use this for, there's a lot of triangulation that's done out in space when we're looking at different planets and stuff like that. They do triangulation on that, which means they look at it straight out and then they look at it in reference to another thing. And so they look for right angles. Right angle is when we're straight out. Okay, thank you. Okay, go ahead and have a seat. And so when we're talking stuff that far out, the decimals are not as important because we're estimating anyway. So they do triangulations of space or stars, of black holes. There's a whole bunch of science that they use with right triangles and this triangulation process, and they can estimate distances based on that. And so that's what they're looking at. Okay, if they know some distance to a satellite, they can use that because they know that distance, and then they make a right angle with that and get it so that they can then find the hypotenuse and stuff. So they use it a lot for space exploration and making estimates of distances. Okay, so that's one usage of it. Okay. That where we can't measure it. I agree, there's other tools that we can use to measure it when it's small. Okay, when it's small.
You're gonna have to get some pretty big calipers there, Harrison.
Okay. Oh, another thing they do use it as is to estimate the height of a mountain, because we will probably know the distance out and up to the top. We know this hypotenuse, we can get that because it's from sea level up to the top of the mountain. You can get that. You know basically what angle it is, so you can find this distance based with trigonometry. Okay, so it's another way to use that they use triangles. Okay, so right triangles and these ratios. Okay, so okay, questions on any of that? We are going to work with that today. Again, one person may solve it differently than another person when we're doing some of the homework, because as you can see, there are many different ways to do it. So one person may use cosine, one person may use sine, one person may use tangent. It's really up to you what you use. As long as you're using it correctly, you should get similar answers.
I guess.
Okay.
More paper.